The last step in cellular respiration is the ATP synthase. Using chemiosmosis, which is the movement of ions across a semi-permeable membrane, the bulk of the glucose's energy is converted into ATP. As described in the earlier video, a hydrogen ion concentration is formed between the two membranes of the mitochondrion using the ETC. This over here is the ETC, this is the outer membrane, this is the inner membrane, this is the matrix, and this is the intermembrane space in the mitochondrion. So in the ETC, hydrogen ions are shuttled across, and so there's an electrochemical gradient that is created. There are a lot more hydrogen ions here, but not as much here. So the hydrogens will want to flow back across the membrane and back into the mitochondrial matrix. Let's call this mitochondrial matrix. And create a so they want to create a hydrogen ion equilibrium. However, as in chemiosmosis, the inner membrane of the mitochondria is semi-permeable. This means that the hydrogen ions can't go back the way they came, or like through the phospholipid bilayer, but it can go through the ATP synthase, which is this right here. So as the hydrogen ions go through, the synthase turns. So I'll just draw like arrows. And so as it turns, the enzymes inside the little knob over here converts ADP and some inorganic phosphates, PI, into ATP. The reason why the inner membrane of the mitochondria has so many cristae, which are the inner membrane folds, is to increase the surface area so more ATP synthases can be there. For example, I drew one like out of the picture over there. And so this allows more hydrogen ions to go back across the membrane and create ATP faster. Altogether, around 38 ATP are created from one glucose. Wow, this is a bad eraser, but I'm just gonna introduce the cellular respiration equation once more. So 1C6H12O6, which is a glucose, plus 6O2, which is just oxygen, can create 6CO2, carbon dioxide, 6H2O, 6 water molecules, and around 38 ATP, which is the molecular form of energy. And that basically concludes all of cellular respiration.